the Large Hadron Collider may have found a groundbreaking new fundamental particle. If confirmed, the particle, possibly a very heavy variation of the Higgs boson, could change our understanding of how the universe works. The discovery was made after physicists spotted unexpected spikes in the data from two LHC detectors. The spikes reach 750 gigaelectronvolts, GeV, and are thought to be the result of super-high-energy proton collisions, according to Motherboard. Both the compact muon solenoid, CMS, and ATLAS, a toroidal LHC apparatus, experiments at the LHC detected the change. At these energy levels, scientists have found an excess of photon particles when heavier particles, such as protons, collide. If these spikes are confirmed, they suggest the presence of a new particle produced in proton collisions. Scientists say it could help them revise something known as the Standard Model, which explains how particles in the universe work. I don't think there is anyone around who thinks this is conclusive, one of the researchers, Kyle Kramer from New York University, told the New York Times. But it would be huge if true. One theory is that it is a heavier version of the Higgs boson, a particle that explains why other particles have mass. Another is that it is a graviton, and its discovery could reveal the existence of extra dimensions of space-time. French physicist Adam Folkowski has been hinting about the results on Twitter for several days. Most likely, this particle would just be a small part of the larger structure, possibly having something to do with electroweak symmetry breaking in the hierarchy problem of the Standard Model, Folkowski writes. If the signal is a real thing, then it may be the beginning of a new golden era in particle physics. But researchers aren't getting too excited just yet. As Gizmodo points out, the most likely explanation is that the observations from the two independent experiments are simply a coincidence. It follows news last month that the Large Hadron Collider has shattered another record, allowing specialists to study a state of matter that existed just after the Big Bang. The LHC recently smashed together lead ions at 1045 trillion electron volts, 2 times higher than any previous experiment of this kind. The experiment reached a temperature of several trillion degrees. Cern accelerator specialists in Geneva worked intensely to reconfigure the LHC leading up to this breakthrough. On November 17, the specialists put the heavy ion beams into collision, and declared them stable days later. It's a tradition to collide ions over 1 month every year as part of our diverse research program at the LHC, said Cern Director General Rolfer. This year, however, is special as we reach a new energy and will explore matter at an even earlier stage of our universe. At the beginning of life in the universe, matter existed as an extremely hot, dense medium. The soup-like medium was composed mainly of quarks and gluons, which now work together to form protons and neutrons. There are many very dense and very hot questions to be addressed with the ion run, for which our experiment was specifically designed and further improved during the shutdown, said ALICE collaboration spokesperson Paolo Giubilino. For instance, we are eager to learn how the increase in energy will affect charmonium production, and to probe heavy flavor and jet quenching with higher statistics. The whole collaboration is enthusiastically preparing for a new journey of discovery. By increasing the energy of lead-ion collisions, the LHC increased the volume and temperature of the soupy matter, quark and gluon plasma. Study of this material could provide scientists with a new understanding of how life began. Further collisions will be recorded by LHC-B, and data will be collected from 4 large LHC experiments. This is an exciting step into the unknown for LHC-B, which has very precise particle identification capabilities, said LHC-B collaboration spokesperson Guy Wilkinson. Our detector will enable us to perform measurements that are highly complementary to those of our friends elsewhere around the ring. In May 2015, the LHC set a new record for smashing subatomic particles together. After a wait of more than 2 years while the world's biggest particle accelerator was upgraded, it reached energies twice as high as possible before. This set the stage for its giant detectors to start exploring realms of new physics such as hidden dimensions and dark matter.